Now we will see how to download the input reads and how to have a preliminary look using sequel. We're going to download the dataset from the group of path Schloss that was greatly described in a Mothur tutorial, and it's labeled as the MySeq in the Mothur website. So this is the page with the full workshop, the full tutorial on how to use Mothur to analyze this dataset, and there is the link to the example data. So it's a subsampling of the full dataset from the paper. So we can wget this zip file. We can decompress the archive. This created the MySeq SOP folder and this unwanted macOSX folder, so we can remove both the macOSX folder and the original archive. In the MySeq SOP folder, you will find a set of paired end reads, so R1 for the forward read and R2 for the reverse read, the composition of the mock committee in FASTA format, and then some metadata files. So we can create an appropriate reads directory where to only put the reads, so mkdir reads. Then we can move all the FASTA files from the MySeq folder to the reads directory. And to save some space, we can compress with gzip the reads, because most bioinformatics programs are already able to read the files in gzip format without needing to decompress them beforehand. For example, we can use sequel to counterreads. Now, since we provided a folder with paired end reads with files that are labeled with the standard R1 and R2, sequel identified that some samples were paired and labeled them as paired, and here it's printing the counts for the R1 files after having checked that the R2 files contain the same number of reads. So this is also some sort of integrity check that we are not having some corrupted file here. An alternative is to use sequelstats. In this case, we can just use the R1 because we already checked that the R2 contains the same number of reads. With -n, we have a 994. We get a table with the file, the number of sequences per file, the total base pairs, and the minimum and maximum read length. So these are Illumina MySeq indeed, 250, and we have more or less more than 5k reads per sample. Again, from the command line, it's useful to have a feedback on the quality of the reads. There are many tools for a visual inspection of the quality. So we can use FastQC, we can use FastP and Data2, and we can have a plot of the quality scores. But if we want to have a first overview, we can use sequel separately for the R1 and R2 because they usually have very different profiles. So here we have, and in the website there is the documentation with all the columns, the minimum and maximum quality that are not really important. They are also used to understand or to infer the possible formats, and in this case it's Illumina 1.8. And here we have the average and the standard deviation of the quality. This is a little bit more informative. And here we have when the quality drops below a certain threshold, so at which position. So there is, how is that threshold calculated? There is a sliding window, and we move it from the beginning to the end, and we stop when one of the two conditions appears, either when the quality is below a specific threshold, or when the average quality in the window is below another threshold. This is applied to the average quality at each position, so a single read is not affecting the result. So if you remember, more or less the quality was good or was okay until 248, but as we can expect for the R2 files, we'll have a slightly different outcome. So the quality drops a little bit earlier, so more or less at 160, let's say. We can use bash tricks, so for example we can sort numerically on the last column. Now we are ready to import our reads.